Okay, you guys, we're starting chapter 12, probability. Again, probability is a little bit of common sense to it. So you can also look at the textbook for a lot of this because that's kind of what I did, or you can watch the video. All right, so we're doing 12.1 and 12.2 today. So an experiment is a situation involving chance that leads to results called outcome. Okay, so possible outcomes or a possible result of something. So for example, if you roll a die, right? Dice. We'll say if you roll a die is singular. The outcome you would get would be like 1, 2, 3, 4, 5, 6. So those are your outcomes. Now an event, just a little vocabulary, is an outcome or collections of outcomes. So then I get a little bit more specific. Let's say you want to do an odd number. So the odd number, the event would be 1, 3, 5. So that's just the definition of them. A sample space. A sample space is going to be a way that you guys list all possible outcomes. That is a sample space. We can represent a sample space. You can represent it by a tree diagram, which I think you guys probably have learned. And I'm going to use a tree diagram. You guys can do a table, or you can see a table, or we can do an organized list. So real quickly, a coin is tossed and then a cube is rolled, represent the sample space. So obviously on your first thing, what could you get if you're flipping a coin? So the coin, you can get heads or you can get tails, right? Then from there, when you have a now you're rolling your die. Did not mean to do that. When you're rolling the die, actually I did mean to do that. You can get 1, 2, 3, 4, 5, 6. Or the first time you guys could have rolled a tails and you can get 1, 2, 3, 4, 5, 6. So that would be like a tree, you know, a listing, an organized list. You could say heads 1, heads 2, heads 3, heads 4, heads 5, heads 6. And the same thing with tails. So there's just different ways for you to represent it. I'm not picky, you know, pick one. Okay, so that's a sample space. You have a couple of problems that ask you for tree diagrams or your sample space. I don't care which one you guys list. The next concept, which is important, is what we call the fundamental counting principle. So it says, for some multiple experiments, listing the entire sample is not practical or it's too much. So to find the number of possible outcomes, we use something called the fundamental counting principle. Really simple. The number of possible outcomes can be found by multiplying the number of possible outcomes for each event. So, for example, first question. A men's department store sells 3 different jackets, 6 shirts, 8 ties, and 4 pairs of pants. How many different suit combinations of jackets, shirts, ties, and pants are there? So instead of listing, 1, 2, 3 jackets, and then 1, 2, 3, 4, 5, 6 shirts, and so forth, what we use is the counting principle, and we just take 3 times the 6, because there's 3 jackets, there's 6 shirts, 8 ties, and 4 pants. So we take this and we multiply, and we do 3 times 6 times 8 times 4. And thank God I would never ask you to write that. That's how many possible combinations there are. That is a lot. Okay, next. If it says 12 students compete in a race, how many first 3 prizes can be given? So if you think about this, I like to do like slots in a way, like this. For the first, how many people could win? You have 12 people, times how many people could win in second place? Think about this logically, common sense. I told you the probability. 1 person won, so 11, and then third place is 10. And obviously you guys can see something, if I were to continue going or ask you for more or whatnot. And this is how many different ways it could happen. Yeah, that is a lot. All right, so let's take a look at our next question. I'm just trying to see something. I guess I didn't do that problem. All right, next read this one. So it says, Juan has 3 blue shirts, 2 green, 7 red, 5 pairs of denim pants, and 2 pairs of khakis. How many different, so here's the thing with this, so I'm gonna start. You can't just read this real fast and say, ooh, let me do 3 times 2 times 7 times 5 times 2, because that's not correct. It says how many different outfits consisting of 1 shirt and 1 pair of pants. So I only want 1 shirt and 1 pair of pants, so really I'm only wanting 2 things. Well, to do this, you have to count how many shirts there are. 3, 4, 5. 5 and 7 is 12, right? Yes. So you have 12 different shirts, and then pants, we have 5 pairs of denim and 2 pairs of khaki. So it'd be 7. So 12 times 7, you have 84 different combinations. It's very different than if you did all of them. So the key thing is you have to make sure you're reading, and you're reading, I guess you can say, the last part of what it is that I want. I'm not so for counting principle, and that is also it for 12.1, which is why it's pretty simple for 12.1. And now we're gonna go into 12.2. 12.2, which is pretty simple as well. Okay, ugh, it's hard to sit on this floor. All right, so we're doing 12.2, probability and counting. So it says you guys can use union and intersection. I believe you guys learned this in algebra. The union of 2 events is the set of all outcomes. We just talked about what the word outcomes means. The set of all outcomes that are in either. So pretty much it's all. That's the way I memorize it. It's all of them. And the way you guys will represent the union, I think it's pretty easy with a U. So just for example, a lot of times, if I said A union B, and I have to give you sets. There's something called sets. You'll see me say like set A equals something, and I'll give you values, and you'll see say set B equals something, and this is a union. I have an example to show you. Now the intersection of 2 events is the set of outcomes that are in common. So it's what they have in common. Well, this one is, either of them, they're all. I kind of changed the words a little bit. So it's what they have in common, and the way we represent intersection is like this. And a way to memorize it, which is really simple, U stands for union, and this, I can put a line through it, and it looks like A. It stands for intersection. Sometimes you guys can think of this in a Venn diagram. So for a union, if you guys have a Venn diagram, what we want is, here's, let's say A, here's B. I want everything of A, and I want everything of B. You would list all of them, okay? Now, if you were over here, and I have an A, and I have a B, you want what they both have. Obviously, the overlapping part would be what they both have, and you would list that. Okay? All right, so talking about probability now. The probability of an event goes from 0 to 1, indicates the likelihood it'll occur. It is the ratio between, what did I write mine I wanted? It is the ratio between the measure of an event so it's like kind of the event, and we could say the measure of the entire group, right? It's like part over whole. And just so you guys see, you guys can write the probability as a fraction, a percent, or a decimal. So just make sure you guys are matching up what the textbook does or what I do. Obviously, either one and any one's acceptable. All right, first problem. So it says a spinner is divided into 8 equal sections, 1 to 8. A is the event that it's an even. So here's what I would say. A, list the outcomes, 2, 4, 6, 8. And B, it's prime. You should know what a prime number is. A number that is divisible by 1 and itself. 1 is not prime because 1 is itself. So 2 is prime, 3 is prime, 5, 7 is prime, and then we're stopping. So if I want the union, think union, marriage, that's the best way. Union is like a marriage. You want everything together. So we're gonna be listing 2, 3, 4, 5, 6, 7, 8. It's all of the outcomes together. Now if I say, find the probability. So now I'm asking you to list and find the probability. The probability is the entire group is 1 to 8. So be careful, that's 1, 2, 3, 4, 5, 6, 7, 8. That's 0, okay. So you have 8 to choose from. And how many do you guys have here? 1, 2, 3, 4, 5, 6, 7. So you can say 7 over 8. You can say 0.875, or you can times that by 100 and get 87.5%. Does not matter. Okay, so next question. I listed you guys a sample space, and it says the outcomes that are common, or I should not say that, the outcomes of E are 2, 4, 6, and the outcomes of T are 3, 4, 5, 6. This means N, so remember it's the intersection, so it's what they have in common. So what do they have in common? A 4 and a 6. There you go. And what's the probability? 2 out of 8. So 1/4, 0.25, or 25%. Next is pretty simple. It's what we call the complement of A. To roll the complement of something, it's pretty simple. Think about this. To roll the complement of not having a 4 and a die, obviously would be 5 out of 6, right? Because you only have 1. Another way people can think about it is you take 1 minus the probability of that. The probability of rolling it, a 4 is 1 over 6. So that's why this is 5 over 6. That's the way, like a lot of textbooks and online are going to explain the way you guys find the complement. They say it's 1 minus the probability of A. This says 1 minus the probability of A. It doesn't matter to me. I kind of just talking to myself and doing the other way, but it's however you guys want to think of it. Okay. Oh, it's floor. Last couple questions and you guys are done for today's lesson. So watch how simple. It says outside a movie theater, 15 people were asked whether they've seen comedy or action. So here's my total. 5 people said they want comedy, 2 people saw action, and 2 people saw both. 6 saw nothing. So I'm gonna go like this, so I don't have to keep looking. 5 comedy, 2 action, 2 saw both, and 6 none. You can also represent this by a Venn diagram. So let me show you if you really wanted. We can say comedy, action. 5 comedy, 2 action, 2 both, and the stuff that goes out there is neither. Let's just double check. 5 and 6 is 11. 11 and 4, 15, okay. So 1 respondent will be chosen at random to win a free movie. Find the probability the winner would have seen comedy or an action. So comedy or action, well, the total amounts would be always over 15, right? So 5 people saw comedy, okay. 2 people saw action, okay. And 2 people saw both. So in the end, we have 5, 6, 7, 8, 9. Gotta make sure you add them all up. It's 5, let's say 2, and then another 2 that saw both. So you could say 9 out of 15, 3 over 5, or 60% of the people. Find the probability that the winner will be someone who did not see action. Okay, so I like to do the bottom first. So who did not see action? Well, these 5 people did not see action. They saw comedy. And the 6 who saw nothing. So 5 plus your 6 is 11 over 15, or 73%, or 0.73. I mean, I probably would leave it as either the fraction or the 73%. Okay? All right, last question. You need to know cards. I'm not sure if you guys know cards, but if not, you have to know them. Real fast, I'm going to review your cards for you. You guys should know you have 52 cards in a deck, right? And then from there, it breaks down to 26 red. So this was a hard time for people. They didn't know their cards. So write this down if you don't know it. And then for the red, you have 13 hearts, and you have 13, oh my God, what's the other one? 13 hearts and 13, just drew a blank. So you have 13 of the black, you have spades, oh, I got it. And you have 13 diamonds. So these are the suits colors. And then you also have 13 clovers? Are they clovers? Huh. No, I can't think. I think they're called clovers. Spades, diamonds, hearts, clubs. Oh my God. Yay. Okay. Clubs? Oh, I don't remember my cards anymore. Hold on 1 second. Make sure I said that to you guys right. It's pretty bad. I told you I feel like I am getting crazy. Did I write my cards out anywhere? Something's wrong with me. All right, well, okay. So we're just gonna leave it like that. And then of the hearts and everything else, you guys have ace. Well, actually, we can like this. You guys have 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. We call this the face cards. So just to review, you have 4 face cards. You know, you have 4. Everybody has a jack. You have 4 queens, but you have 2 red queens. You have 2 black kings. And then it's obviously, again, 2 through all the way 10. So make sure you guys look at your cards. I did hope I said that right. But anyway. So coming back to this, you know, what's the probability you pick a king? So it's out of 52 cards, and how many kings are there? 4. 4 out of 52, we can leave as, well, it'd be nice if you guys would simplify, or you guys can kind of make it a fraction. You can simplify, or you guys can tell me it as a percent, which is 0.076, so about 8%. That's a really low probability. A red queen. Well, how many queens are there that are red? 2. 2 out of 52. Which is very small, 1 out of 26. So I want your fractions always simplified. Or you can tell me it's about 4%. A spade, how many spades are there? That's a suit. So there's 13 of them. 13 out of 52 is 1/4. That was dumb, I should have done that in my head. Or 25%, and that makes sense because you have 4 different suits. And what about a red card? Well, there's 26 red out of 52, so 1/2 or a 50% chance. So that's your basic intro to probability. Hopefully you guys thought the lesson was pretty easy. And that's it. Okay, 12-1. This was 12-2, and you guys learned 2 lessons.